I pulled up the NASA website. Let's read about this DART and see who's on target. So, upcoming pretty soon, we have the DART Asteroid Redirect Test. Gotta love NASA. So within, so without. So, what people fail to realize about NASA, okay, they project things out way out in the future. They make you seem like it's so far off that you don't have to worry about it. And then people don't think about like nuclear science and internal science, that our bodies are made up of the same thing. So, in other words, what they're talking about is internal, not out in space. It's in your mental dome. Things that make you go, Didymus. Didymus the blind? Or Didymus the twin? Food for philosophy, thought, and hermetics. So, to help me along tonight, I am using my handy dandy, bam, notebook. So, let's read. The Double Asteroid Redirect Test mission is directed by NASA at the Johns Hopkins Applied Science. That's not what it says. That isn't. Take two. No, what it said was the Johns Hopkins Applied Physics Laboratory. Yes, that's what it said, with support from several NASA centers: the Jet Propulsion Laboratory, JPL, Goddard Space Flight Center, go get 'em, like Mike Tyson, Johnson Space Center, Glenn Research Center, and Langley Research Center. DART is a planetary defense-driven test of technologies for preventing the impact of Earth by a hazardous asteroid. Now, we've heard this before, so you guys don't freak out like, oh my gosh, he's saying something we've never heard. This has been done before. I'm not telling you anything really new, nothing new under the sun. But this is the cycle, so we're back here, so let's have a little fun. Okay, so where were we at? Preventing an impact on Earth by a hazardous asteroid. DART will be the first demonstration of the kinetic impactor technique to change the motion of the asteroid in space. The DART mission is in Phase C, led by APL and managed by NASA's Solar System Exploration Program at Marshall Space Flight Center for NASA's Planetary Defense Coordination Office and the Science Mission Director's Planetary Science Division at NASA's headquarters in Washington, D.C. Why did Kanye West just come to mind? Him and his mask that he wore, how he's been wearing the full facial mask. It's supposed to be a Caucasian woman, but it looked kind of like Marshall Mathers, kind of Eminem-esque to me. Anyway, side note, back to the story, article. Back to these messages. DART is a spacecraft, if I could say it, spacecraft designed to impact an asteroid as a test of technology. DART's target asteroid is not a threat to Earth. Thank you, Mental Dome. Glad to know that, self. Earth is not affected. This asteroid system is a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course, should an Earth-threatening asteroid be discovered in the future. Nothing new under the sun. Future, past, it's all the same, just a little fun. Okay, well, no one While no known asteroid larger than 140 meters in size has had a significant chance to hit Earth for the next 100 years, only about 40% of those asteroids have been found as of October 2021. Then we have the picture. See, if you want to see. The binary near-Earth asteroid 65803, DIDYMOS, is the target for the DART demonstration. DIDYMOS. Okay. While the DIDYMOS primary body is approximately 780 meters across, its secondary body, or moonlet, is about 160 meters in size, which is more typical of the size of asteroids that could pose the most likely significant threat to Earth. The DIDYMOS binary is being intensely observed using telescopes on Earth to precisely measure its properties before DART arrives. The DART spacecraft will achieve the kinetic impact deflection by deliberately crashing itself into the moonlet at a speed of approximately 6.6 km with the aid of an onboard camera named Draco. How surprising. Draco. It's that season. Anyway, and sophisticated autonomous navigation software. The collision will change the speed of the moonlet in its orbit around the main body by a fraction of 1%. But this will change the orbital period of the moonlet by several minutes, enough to be observed and measured using telescopes on Earth. Once launched, DART will deploy rollout solar arrays, ROSA, to provide the solar power needed for DART's electrical propulsion system. The DART spacecraft will demonstrate the NASA Evolutionary Xenon Thruster, Commercial, NEXT-C, solar electric propulsion system as part of its space propulsion. NEXT-C is a next-generation system based on the Dawn spacecraft propulsion system and was developed at NASA's Glenn Research Center in Cleveland, Ohio. By utilizing electric propulsion, DART could benefit from significant flexibility to the mission timeline while demonstrating the next generation of ion engine technology, with applications to potential future NASA missions. The DART spacecraft. The launch window begins November 24th, 2021. That's very soon, you guys. DART will launch aboard a SpaceX Falcon 9 rocket from Vandenberg Air Force Base here in California. After separation from the launch vehicle and over a year of cruise, it will intercept DIDYMOS's moonlet in late September of 2022. When the DIDYMOS system is within 11 million kilometers of Earth, enabling observations by grounded-based telescopes and planetary radar to measure and change the momentum imparted on the moonlet.
Asteroids and pieces of asteroids all the time. Every year or so, we get hit by things maybe the size of a table. The kind of object that DART is going to visit is an object that's about the size of the Washington Monument. Those kinds of objects hit us every few thousand years, and they would cause severe damage on a regional scale.
We chose to do this demonstration at a binary asteroid. It's called DIDYMOS. This is actually approximately the shape of the main asteroid. It's called DIDYMOS A, and its moon, DIDYMOS B. What DART will do is DART will hit the secondary. When it hits the moon, it will change the orbit period. And when it changes the orbit period, it affects the timing of when the moon moves in front of or behind the primary.
Mostly what we're looking to do is change the speed of the incoming object by maybe a centimeter per second or so. So that's not very fast, but if you do it enough seconds in advance, you can cause it to miss the Earth entirely.
DART is a part of a larger collaboration called IDA, which pulls in all the experts of the world who can help their governments predict and understand what it is that they can do and should do in the event that there was an incoming threat. The DART mission that APL is pulling together will be the first mission in that flight line.
DART is the first mission to fly the next sea ion engine. It is the first mission to demonstrate smart navigation, which means we're going to be guiding ourselves into the asteroid autonomously.
Right about 4 hours out from impact, Smart Nav is kicked in, and what it does is it uses the imagery from the optical payload, basically the camera that's on DART, and from the imagery we are able to discern Didymos A from Didymos B. We have a targeting algorithm that differentiates the two, and we are aiming for Didymos B.
The other part of this is the propulsion system that we're demonstrating. The next sea propulsion system is utilizing a new generation of gridded ion propulsion technology, and it's what we're using to allow us to get to the asteroid, but also allow us a flyby of an object prior to our actual encounter.
For this vehicle to be able to supply the power for the electric propulsion engine, we needed higher power output. ROSA allows us to be able to have a very compact and light mass for launch and then deploy these really large arrays once we're out there in space.
Our planetary launch window opens on June 15, 2021, and will impact the asteroid in 2022. We're very excited to be NASA's first planetary defense mission.
Couldn't help but notice that the Didymos is also what attached to? The ball sack, you say? The scrotum? Well, I'll be. Ain't that nuts?